Welcome to this basic introduction that'll give you a good starting point for your further application of GRASP for reflector antenna design and analysis. In this video, we'll demonstrate how you can easily define a reflector antenna geometry, perform an analysis, and inspect the results. GRASP has a wizard that automates a lot of the initial steps, and it requires only very few inputs from the user. The wizard is available from the Startup dialog and from the Wizards menu in the Antennas and Scatterers tab. We'll look at an example based on a real radio astronomy antenna making observations in the 3mm or 100 GHz band. I set the frequency to 100 GHz and the dish diameter to 20 meter. The wizard informs us that the size of this antenna corresponds to more than 6,600 wavelength, so we're indeed looking at an electrically very large antenna. The focal length of the dish should be 9 meter, which corresponds to an f/d ratio of 0.45, which is what we specify here. We wish to avoid any disturbance of the aperture field, so instead of having a center-fed configuration, I will make it offset. This is controlled by the parameter reflector offset relative to reflector diameter and specifies how far from the axis of symmetry the center of the aperture is displaced. So setting it to 0.5 corresponds to the edge of the reflector. This would still give some blockage due to the feed, so we set it to 0.55 instead. In this example, I'm using relative values to define the geometry, but you could also use absolute values by simply changing the setting, use absolute or relative values. We now have a design that we want to analyze and ask the wizard to generate objects, the basic building blocks of any GRASP project. These can be seen in the Object Explorer tree here. I'll only mention one of them, the feed, since we haven't discussed this yet. The wizard automatically selects the model, the feed, as a Gaussian beam with a taper of -12 dB at the edge of the reflector. This is known to be a good compromise between aperture efficiency and side lobe levels. It can, of course, be changed by the user. If we go to the Commands tab, you can see that the wizard has also generated the commands necessary to perform a physical optics analysis of the antenna, and we can simply click the play button to run. Before the simulation runs, we need to save the project under a name of your choice. The analysis is completed in a split second, and we can go to the Results tab to see the antenna pattern. It's been computed at 100 GHz in 3 cuts: 0, the plane of offset, 45, and 90 degrees. To see them all, I double-click the 100 GHz label. We see an antenna pattern with a gain of more than 85 dBi, slightly asymmetric in the plane of offset and perfectly symmetric in the 90-degree plane as expected. The cross-polarization is fairly high, which is well known and caused by the offset geometry. You may now use the project for further investigations, for example, to change the feed taper or to extend the angular range where the field is calculated. I thank you for watching, and I recommend that you watch our other GRASP introduction videos to learn more about the different types of objects and commands used.